All right, so we are going to find all sorts of information out about hyperbolas. So with hyperbolas and ellipses, or a hyperbola or an ellipse, you always want it set at equal to 1. So I'm going to reorganize this first. I'm going to get my x's together, my y's together, and my constant on the other side. So what I notice first is I have an x squared minus a 4x, and then there's no more x's. Then I have a minus y squared minus 8y, and then there's no more y's. And I'm going to kick this 13 to the other side by adding him. So I end up with equals 13. And then I'm going to do one more thing, which is a place that people may trip up. Remember, you want this to lead off positive. So I'm going to factor out this negative right here. So I'm left with an x squared minus 4x and then minus y squared plus 8y. And that's going to equal 13. So why do I have so much room? Is because I'm going to complete the square. So if I have a coefficient of 1 and then an even what's fixing to be my middle term, then I can complete the square by taking half of this, which is negative 2, and squaring it. So negative 2 times negative 2 is positive 4. So I've created a positive 4, so I better create it on both sides. And then I need to do the same thing with my y terms. So what's fixing to be my middle term is 8. So half of that is 4, squared is 16. So I've created a 16. But wait, no I didn't. So this says minus, okay? And so really and truly, that's a negative 16. So be very, very careful when you factor out this negative, or if you need to factor out a constant, make sure that you remember exactly what you have created. So really and truly, I've created a negative 16. So I need to do minus 16 on both sides, because if I distribute that negative, that's a negative 16. So why do I want to do all this? Because when I factor this, two numbers that multiply to 4 that add up to negative 4 are negative 2 and negative 2, which means I can write this as x minus 2 squared. And now I have this minus. And then what are two numbers that multiply to 16 that add up to 8? That's going to be positive 4 and positive 4. So I have y plus 4 squared. And then when I add this across, I've got 13 plus 14 is 17. Minus 16 is 1. So as we said at the start of the video, we want our hyperbolas and our ellipses to be set equal to 1. So parabolas are a whole other issue. But this is now set equal to 1. So if this wasn't set equal to 1, I would divide, like if this was a 4, I would divide everything by 4. Okay, but it's not, so I'm not going to. Well, what that means is that this is a 1 and that this is a 1. Okay, so first of all, I know it's a hyperbola because I've got a chunk squared minus a chunk squared equals a number. If this was addition, it would be an ellipse. Okay, but it's not. So whoever is positive, I like to say he's in charge. Okay, so first of all, I know that the actual symmetric center of this thing is at positive 2, negative 4. So change your signs. So if I plot this thing, I'm going to be at positive 2, so 1, 2, and then negative 4. So 1, 2, 3, 4. So that is the symmetric center. Okay, now I want to find out what my distance is. And so looking at this denominator and this denominator are both 1. Remember that those are squared values. So this is the same thing as 1 squared, okay? If this was a 4, you would rewrite it as a 2 squared, okay? If this was a 16, you would rewrite it as a 4 squared. But you want this term in your denominator to be squared. So I'm going to remember that that's a 1 squared and that that's a 1 squared. Okay, so I want to start by looking at what my focal axis is. In other words, what is the axis upon which my foci are laying? Okay, so since your x's are positive, that means that this is going to open to the right and to the left. If you were leading off with your y's positive, that means he would open up and down. but I do know that this is going to be a left-right. Well, I also know that this focal axis is going to slice right through that symmetric center. And so what is the equation of that horizontal line? The equation of that horizontal line is y equals -4. So my focal axis is at y equals -4. I slice through the y-axis at -4. And I just pulled that from the y-coordinate of my symmetric center. So now what do I want to know? I want to know what the foci are. Where are the foci located? Well, I know that they're going to be located left and right from my symmetric center. So when I look at that, this is where my a's and b's come into play. So this is going to be an a squared, and this is going to be a b squared, and then my Pythagorean relation is going to be the fact that those added together equals c squared. So this is a true Pythagorean relation. In other words, a squared plus b squared will equal c squared. So if I know that a squared is 1 squared, okay, plus b squared is 1 squared, that's going to equal c squared. So 2 equals c squared, which means my value for c is going to be plus or minus the square root of 2. Okay, so what does that mean? What do I do with that information? That means that from the center, I'm going to go to the left that much, and I'm going to go to the right that much, and I'm going to plant those things. So remember that this is a little bit shy of 2. It's about 1.7 something. Okay, so if this is plotted at 2, then that means I'm going to go this far, which is almost 2. And then I'm going to go this far, which is almost 2. So what are those two coordinates? Well, if my symmetric center is at 2, -4, then I would have 2 minus root 2 at -4, and I would have 2 plus root 2 at -4. And it looks kind of messy. Just remember that if you needed to, you could put that in the calculator to get a decimal approximation. But what this is an exact answer. So from 2, I would subtract root 2, so I go this way, then I'm staying at -4. And then from 2, I would add root 2, but I'm still at -4. So those are the coordinates of your foci, okay? Well, now I want the coordinates. I just said foci, but I wrote focus. Focus. So this is plural, so we're going to call it foci. All right. So now what I want is the vertices. So again, the vertices are going to be found by adding or subtracting to the left or to the right. And I know it's left or right because I led off with a positive x. So how do I know where to find my vertex? Well, I'm going to add the value for a, okay, left and right. So remember, a is attached underneath what you're leading off with. So this is 1 squared, that's a squared. Well, I also know that that is, the square root of 1 is 1. So from here, I'm going to subtract 1, and then I'm going to add 1. Okay, so those are the coordinates for my vertex. So how do I write those? My vertices, or my vertex, each one, plural. Vertex is singular, vertices is plural. Is I'm going to take my starting coordinate, and I'm going to subtract 1. Well, 2 minus 1 is 1, and I'm still at -4. And then I'm going to take my coordinate and add 1. So 2 plus 1 is 3, comma, -4. So those are my vertices. So in a very, very trashy drawing here, this is what this thing looks like. So I don't really know. This is my sketch. Okay, I don't know what that coordinate is, and I don't know what that coordinate is. This is just a rough sketch. So this is the setup for my hyperbola. So what I would like to look at now is how on God's green earth do I find the asymptotes. Okay, so my asymptotes are going to be found after I grab a new pen color. So my asymptotes are going to be diagonal, and they're going to slice right through that center point. So my asymptotes are going to be found by y minus k. Well, what's my k? Okay, so I'm going to look back up here, and I'm going to remember that this part is y minus k squared, which means I just need to take this y plus 4, okay? So my asymptotes are going to be y plus 4 equals, and then I need to take my x chunk. So my x chunk says x minus 2, so that's going to be x minus 2. And then I need a ratio in front of it for as far as how the slope moves. So it's going to be plus or minus, and then it's going to be b over a, okay? Or the value underneath the subtraction chunk over the value underneath the positive chunk. So this is 1 squared, so his value is 1. This is 1 squared, so his value is 1, so I have plus or minus 1. So be careful when this is two problems working at the same time. Okay, so at this point, I have a y plus 4 equals a positive 1 times x minus 2 is x minus 2. And then a negative 1 times x minus 2 is going to change all the signs. So that'll give me a y plus 4 equals a negative x plus 2. Whoa! Okay, so change your signs. And now all I've got to do is throw that 4 over to the other side, and I will have the equation of my asymptote. So that gives me x minus 6. So my slope would be 1, but I would slice through the y-axis at 6. So I would end up having an asymptote like this. And then this one, this is not very well organized, I apologize, is y equals negative x, so a negative slope, 2 minus 4 is a negative 2, so he slices through the y-axis at negative 2, and he has a negative slope. And that is the extremely rough sketch of what my hyperbola looks like. And that is it for this section.